Hello, I'm Charlie Armstrong, and this is my thesis demonstration of applying depth-aware interpolation to 2D animation. In general, nearly all of the content is covered by my thesis report and the HTML file of my experimentation Python notebook. I made sure to include notes explaining everything that was done and most of my thoughts on why it was happening and things that could be improved. So I thought I would just use this opportunity to demonstrate some of the outputs, which you kind of need to see the video to understand, since I couldn't include video files in the Python notebook or the report, only specific frames. So this is a clip which I tested on before running the interpolation on it, which I picked because it has quite a lot of movement, characters being obscured by other objects or coming in from the side of the frame, and panning shots where the scene is being panned across at a different frame rate to the motion within the scene, or where a character is moving at a higher frame rate than the background is animated on. And it's downscaled to 360p just because I don't have the memory to run the interpolation on HD files. So as you can see here, the focus of the scene is quite obvious, but the visuals are kind of quite abstract, which is why I had so much trouble trying to see if there was any kind of method to detect which regions are what, although the foreground object is in a more simplistic cartoony style, whereas the background is more of a painterly-ish style, which does make me think there's something more to using style transfer to detect the elements, which I showed a bit of in my Python notebook. But anyway, in terms of the interpolation, you can already within the first second kind of see the issues that come from only 2D drawn animation, where there's multiple frames which are exactly the same, which you generally wouldn't get with live action footage, or you can see that there are frames where only those background curtains are starting to move in and out, and then the next frame only the foreground character moves, things like that. And there are some more traditional interpolations type elements present in this example as well, like characters being obscured or occluded by foreground objects or new objects coming in from the side of the frame. Oh, and you can see with this background here as well, some of the motion is kind of quite fast, so it would be difficult for any interpolation for that background to happen here. And this is another example of the actual animation and the background being on a different frame rate there. So just as an example, this is from the original creator of depth-aware interpolation network, but from my experimentation, using optical flow on animation definitely did work, but of course estimating depth doesn't really apply to that whole field, which is why I tried to look into ways of isolating the specific elements. But you can see here that it does do well when there are no duplicate frames at all, and in general with occlusion with those pillars moving with the changing angle in the background, it works fine as well, and with the guy coming in from the side. So if I use FFmpeg to convert a video into downsized frames, all with a regular file name, then it's as simple as just activating my customized code to interpolate a frame between each of those. And you can also set it to interpolate more than one frame between each pair of two original frames. So here are all the output interpolated files. Then I just needed to write an algorithm to rename and sort them all in such a way that I could use FFmpeg to recombine them all back into a video. But yeah, you can see here these are only the interpolated frames, not mixed back with the actual frames, but you can see quite a few of them are duplicates because the original frames were duplicates as well, but it still interpolates them. Here you can see some occlusion. Obviously this looks better when mixed back with the actual things, but it can kind of detect the movement between those leaves, but the optical flow wise, but the interpolation itself is messier than with live action footage. Although treating the thing that's being uncovered by the occlusion as the background seemed to work quite well there. Here's one of the obvious things that would be quite easy to fix by interpolating separate scenes separately. The last frame of one cut and the next frame of another cut getting merged together there. But you could use simple shortcut detection to solve that issue. Here you can see, obviously again this is only the interpolated frames before it's mixed, but it actually did quite a good job at interpolating the movement of the background, even though it's quite abstract. But as you'll see in a moment, once the foreground characters start coming in, the optical flow of the background, which is kind of an upwards one, starts to get mixed in with the inwards movement of the foreground characters. You can see the hair getting interpolated upwards for a frame there, things like that, which is why interpolating the foreground and background elements separately would be better. Here is just the movement is especially complicated in this one. There's camera movements, zooming out, moving around at an angle, and then foreground occlusion, lots of small elements, and then the grass comes in from the bottom as well. This was just probably too complicated of a scene for Dane to do efficiently, although it does do it still quite well when you put back the original frames as well. It's only really when thinking about the accuracy that a professional studio would want from this technique that it's not really up to par. And here's just another example of the background moving separately from the foreground character. You could probably have this effect in live action as well actually, but the foreground character starts to move backwards as well as the actual background, and the interpolation messes up a bit with the optical flow. So anyway, here they are side by side in the top left and the top right, as well as in the bottom left is another version I did after using the FFmpeg MP decimate technique to remove a lot of the duplicate frames, which solves the issue where the duplicate frames get interpolated and it gives the effect of a slower scene when there's not such movement, and then suddenly speeding up for the movement and then slowing back down again. But as you can see, obviously it also had the effect of making the overall thing a lot faster. I think this could probably be solved by just writing some code to place those frames back where they originally were in the same time span. Anyway, thank you for watching. I thought that showcasing some of the things I was saying about the video files and interpolation, etc., would be more useful than reiterating a lot of the points from my code and from the thesis. So I hope that you find the report and the code easy to understand as well. Thank you.